Hello. Today we're going to be talking about binary addition. Let's begin with a pretty basic recap. Today we're dealing with the binaries. Binary only utilizes two digits, a 0 and a 1. We've seen this in our past couple videos. Today we're going to add binary values together and try out some examples. Adding binary is a very integral part of computer science, and all of the things we're going to learn in the later episodes and in the future. This is a very good basic video to start understanding how to do it. First, binary addition is super simple math, and the way we can prove that is start with an example. Let's say we want to add 0, 1, 0, 1, 0, 1, 1, and 1, 1, 0, 0. If we convert these to their decimal equivalents, we get 13 and 11 respectively. If you're wondering what this hashtag in front is, that is literally to delegate what is decimal. This is a decimal sign. A B is for binary, and an X is for hexadecimal. This is more important later on, but for right now, I'm just letting you know what this hashtag in front means. Now, let's work through an actual example. We have 13 on top, 11 on the bottom, and our addition works very similar to normal addition. We start in the rightmost column, and we work leftward. And every time we get a value that's too high, we carry it over. Let's add 1 and 1 together. When we add these together, we're going to get 2. But wait, we can't put 2 inside of a binary value. The only digits we have are 0 and 1. That means that this is going to be a 0, and we're going to carry over a 1. If you think about this logically, 1 plus 1 is 2. How do we represent 2 in binary? Binary 2 is 0, 1, which we have right here. So now, let's continue working through this question. We carry over the 1, have a 0 down here. Then we add together 1 and 1. Should be 0 again, carry over the 1. 1 plus 1, 0 again, carry over the 1. Now we have 3 1s here, which will give us a 1 here and a carryover 1, which gives our final answer of 1 1 0 0 0 in binary. If we convert this to hexadecimal, we get 24. Which is exactly what we expected. Perfect. That means our answer is 11000. Wonderful. That's it. That's all of binary addition. It's very simple, but it is one of the most integral parts of how a computer works. Let's go over a couple more examples to make sure we understand the concept. 101, what is this in hexadecimal? In decimal? 5. And 11 is 3. And we should get 8. Now let's add together and make sure that works. 101 plus 11, add the 1s, a 0 with a carryover, add the 1s, a 0 with a carryover, add the 1s, a 0 with a carryover again. And we get this value, which is equal to 8. Perfect, we got that right. Wonderful. Converting to decimal is a very good way for us to check any of these values, and we can make sure we're doing our math right. Second example, we can do, leave some room for myself, 0 1 1 1 plus 0 0 1 0. Now we can add the 1 and the 0, bring a 1 down. Add the 1 and the 1, we get a 0 with a carryover. 1 plus 1, again a 0 with a carryover, and these two add together. That gave us 1 0 0 1. This in decimal equal to 9. And then we have 2 and 7, which means we got the correct answer. Perfect. Now let's talk about an important part, overflow. Overflow is what happens when we have a restricted number of bits. Say, for example, we only have 4 bits. That means we only have 4 locations that we can store our final value in. So if we have a number that's like 1 1 0 1 1, this last one would not be stored. So let's look at this with an actual example from what we worked through before. Adding together 13 and 11. If you remember, we got the answer 24. Now, 24 might not actually fit. When we have only 4 digits available, we can't store the last digit anywhere. It becomes lost. So now, if we go through our math again, 1 1 0 1 and 1 0 1 1, when we add these, 0 with a carryover, 0 with a carryover, 0 with a carryover, and a 1. But this final carryover bit is omitted. We have nowhere to keep it. That means that our answer, instead of being 11000, would be converted into 1000. That means we dropped down from 24 to 8. This is a pretty big issue, but it's something we deal with a lot in computer science and something we found ways to solve. So think about overflow and make sure you understand how binary addition works. Thank you.